Hi everyone, good morning, good afternoon, good evening, wherever you are.
Hey,
We're
hi
back again
everyone.
with our live stream. So we are back again with our live streams, and this time it's very interesting. We both, Sonia and I, and we have a cool friend with us, Patch.
Patch is with us.
So we are here to discuss about OWASP top 10 vulnerabilities, and we would be showing demos. We would be showcasing bunch of resources with you. And we would also be taking you through different aspects of those vulnerabilities. It is not just going to be done today, it's a part series for 5 days. So you will be seeing us almost every day. So today, tomorrow, day after, and 2 days after that. The whole week we have dedicated to OWASP top 10, and we would be picking up one vulnerability each and sharing the aspects of those vulnerabilities. The most important aspect for these session is to educate you all about the big fix. Now I will bring the screen um, on the board and we can talk about more. Sonia, do you want to talk about Snyk big fix a bit?
Sure. So the Big Fix event is 1 month event that we can call like a month-long fix-a-thon, where you actually fix your security vulnerabilities if you have some in your projects, open source projects, or also closed source software projects. And when you do so, you can actually win prizes. So as I said, this is from the 14th February, so it started last week, and it's until March 14th, so a month long. And if you go to this page, Vandana, if you can share the link for our audience, you can actually win cool prizes. So if you fix at least one vulnerability, you will get this limited edition T-shirt. But if you manage to get the first place, second place, or third place on the leaderboard, so we also do have cool leaderboards. When you fix your vulnerabilities, you can see and be competitive. You can earn a VR headset, a wireless speaker, or an Arduino starter kit. Um, and also, Vandana, there's also a live stream, a 24-hour live stream on 28th of February. So for all regions, for APJ, EMEA, and AMER, we do have really cool schedule with a lot of interesting talks. So yeah, if you want to learn more about securing your projects and learn more about security, just join us during this 24-hour live stream as well.
The fun fact, it's going to be run by us. So I would be taking care of APJ, Sonia would be taking care of EMEA, and then we have people taking care of Amir as well. So we would be covering the whole 24 hours. We would love to see you joining us. The whole schedule is live on the website, and you can check out who all are speaking. And we would love to have your support for these sessions. Uh, and the interesting part that there would be gifts, but then there'll be cool swags as well, which we would love to ship you when you fix the bug in your own project as well. So we have crossed 100,000 bug fix and whatnot. So we would like to have you also as part of. Um, oh my God. Okay. Yes. If you see the total fixes are around 100,000, but yes, okay, there'll be more and more, and we have a goal for 200,000. I am sure, Sonia, we can do it. We
Yeah,
can
let's
reach
do
that
this.
number.
Yeah, let's make it
Yes,
a little bit more secure. Your open source project. Let's do this all together.
absolutely. Now, let me remove the screen and we talk a bit about what we're going to be doing for the upcoming days. So, we would start off with broken access control, and we will also do SSRF, which is server side request forgery, as mentioned on the stream. But before that, there is one interesting thing that we want to talk about is Snyk Learn. That what is Snyk Learn? Sonia, do you want to talk about that?
Sure. So Snakelearn is our online platform where you can learn about securities with interactive lessons. So that's cool. It's like hands-on labs. And we do have a lot of lessons covering ecosystem. So yes, you sure. Thank you, Vandana, for sharing the link. So if you go here on the Snakelearn platform, you can click on lessons. And as you can see, there's a lot of lessons actually. And the good thing is you can set up an account, and as you can see, it keeps progress. So if you don't have time to complete the entire lesson, you can come back. You can also filter by categories and ecosystem. So you can see like JavaScript, Python, PHP, C Sharp, Java, Go, and Kubernetes. And we keep adding new lessons every time. And the good news is we also have learning paths, and this is what we're going to talk about today. So we do have the learning path around the OWASP Top 10. So if you click on it, you'll have a curriculum of 10 lessons, which covers the OWASP Top 10. Isn't it cool, Vandana?
Absolutely. I totally love it. And especially all of these OWASP top 10 list, it's the latest one, which OWASP released in 2021. So learning about all of these, and then it's an interactive one. How cool that would be for anyone, for me, for a security person, for a developer, anyone who wants to know about these bugs. And if you want to know more about, you can hear these sessions anytime. They will be on YouTube, and you'll be able to hear every session. So we are trying to make it as part series so that we can spend more and more time on these vulnerabilities to talk about what are they, how you can exploit them, how exactly these vulnerabilities are replicated. Also, mitigation. If we don't do the defensive section, I think we are going to miss out on a lot of stuff. So we're going to be discussing it, and our friend Patch, he's going to help us out for understanding these vulnerabilities and sharing the bugs with you. After this session, you can go back, you can try it yourself as well. You don't need to wait for us to give you the access, because they are open. They are there for you to learn. And if you want to have if you want to share any suggestion about these vulnerabilities, about these sessions, we would love to hear about that as well. So now, without further ado, let me go ahead and we will get started with the sessions. But Sonia, we didn't introduce ourselves.
That's true. We're like in a rush. We just want to learn with everyone. Well, let's introduce ourselves. Vandana, start. Yeah, introduce yourself.
All right. Hi, everyone. I'm Vandana. I am security advocate for Snyk from APJ region. I'm based out of India. And I love working on these lessons, training people. This is my bread and butter, and this is something which I totally love it. Now, Sonia, over to you.
I'm Sunny. I'm a senior security advocate at Snyk, based in London. Yeah, representing MEA. Yeah, also really passionate about education. So yeah, let's dive in. Let's start with the first lesson, broken access control, because this is what we hear today. So let me have a look at this one. Cool. So broken access control, what it is. So it's making sure we authenticate and authorize correctly. So let's have a look at the basics. What is broken access control? Just going to zoom in a little bit more. So yeah, that's better. Cool. So access control refers to the permission structure that should be refined by the application. For example, your application may have separate roles for regular users and administrator. Regular users should not be able to obtain privileged access, but administrators should. Yeah, obviously we don't want to have regular user to have admin rights. So when the access control of an application is broken, a regular user may be able to access functionality that is meant to be reserved for administrators, or perhaps they can access data that doesn't belong to them. And this is not great. We don't want to have that. So what we're going to see about within this lesson. So in this lesson, we'll learn about how broken access control vulnerabilities work, how to protect your applications against them, and we'll step into the shoes of a devious college students who exploits one of their university web applications to award themselves an unearned high distinction. Oh, interesting. So I think they're going to change their grades just to have potentially A's instead of F's. So we'll have a look at that. But first of all, a fun fact around the OWASP Top 10. So broken access control has recently taken the top spot in the venerable 2021 OWASP Top 10 list, knocking injection out of the first place for the first time in the list history. So this is a sign that broken access control is highly prevalent and presents very significant risk to organizations today. But first of all, let's see the definition between authorization and authentication. So before we start, there's one important distinction to make between both terms. So the first one, authorization and authentication, they're quite similar words. They're often confused. So it is important to know the difference between them. First, authentication is the process of determining who someone is, while authorization is the process of determining what that person is allowed to do or what they have access to. So when people talk about broken access control, we're referring to authorization and not authentication. This is important to make the distinction between both terms. So let's see in action. So in this example, we're going to have a student named Ezra, which is a particularly intelligent college student with a penchant for hacking and a willingness to break the law for personal gain. Ooh, with the noti emoji. Okay. So this semester, we really want to pass a statistic class in order to graduate with a computer science degree. So the thing is, the exam is today. We slept through it because we're late night hacking last night. And we could pay thousands of dollars and wait 6 months to retake the exam, or we could put those hacking skills to work. It wouldn't hurt to just take a look. Okay, well, everyone, this is not great. This is not ethical hacking. This is not great, but this is just for the example. Okay, so we're going to sign into a web application that allows us to check our grades. So this will be the endpoints. And we pass every subject except statistics, and currently shows an F or fail. Okay, cool. So usually for each of the lessons, you would have like a sandbox where you can actually try the vulnerabilities. So let's try this one to test for broken access control. The first step. So let's see if the following websites, so this one, is secure and protect against broken access control. We'll need a proxy interceptor, but let's start the attack. So if I press start here, so here we have the websites at the top. At the bottom, we have the proxy. So this could be Postman or a Burp Suite or any other tools that allow us to proxy the request. And we can see here the student ID and all the subjects and the grades. So we can see math, there's B, physics, English. It seems that everything is in green, apart from this one, statistic. It's red now with F. And here in the proxy, we can see the GET requests with the grades endpoints. You have the student ID, the subject ID, and yeah, and the endpoint. Cool. So let's send this request. Let's see what is coming back. So here we're having 200, so it's okay. And this is what is within the JSON file. So we have the subject ID, the student ID, and the grade. So yeah, and more importantly, we have the failing grade, and this is the one that we actually want to change. So let's edit this request to see if we can get an A. So you might be thinking, isn't it this easy? Actually, you can just change the grade and send the request, and this will change your grade. So let's try. Let's edit this one. So here we can see that we've actually changed the grade, but also we've changed the requests. So what do you say? I think this might work. Let's change the get request to patch request. So this means to upgrade the F to an A. But surely the school must protect against this attack. Surely. Let's see. Let's send this request. Ooh, it did actually change it to A. And we can see the response here. The status is the grade updated successfully. Okay. Apparently not. Maybe we should take a look at our other grades and see if we can make an improvement. The attack was successful. Yeah, so you can imagine Ezra, the students, actually changing all of his grades to from B to A. Yeah, and here, so you have a demo about broken access control, but just like changing the grades from F to A, which is not great. Cool. So let's have a look and understand a little bit more about insecure direct object reference, called IDOR vulnerabilities. So if you're really observant, you may have noticed that the get grade route also doesn't contain any access control restrictions. This means that an attacker could easily view the grades of other students by guessing a valid student ID instead of their own. So for example, if your student ID is this one, so sending this request will return your grade. So using the endpoint with the get request, you're actually adding this here for the student ID and the subject ID. So depending if this one is statistics, for example, and then you send this request. But if we simply change this student ID with this one, then we would return the grade of this particular student. And we can actually see his or her grades, which is not great. So with a few minutes of coding, this process could be automated to download the grades of thousands of students. So let's see, for example, by using the Access package to fetch, so we'd have a for loop here, and you can see getting this endpoint and adding the ID, and doing this for all of the students by concatenating the students 2022, the ID, the grades, and then getting all the grades, and then you can, as I say, download all the grades of thousands of students. Cool. So how does it work under the hood? What just happened? So what you just witnessed was a classic instance of broken access control. So of course, a student should not be able to edit their own grades, but the API didn't properly enforce role-based restrictions on the server side. So while students do not see any method of updating their own grades within the UI of the application, you are still able to send specifically specially crafted row HTTP requests directly to the API to make these changes. And we've seen it with the patch request. So here, for the sake of simplicity, we skip any error checking in the example code. Let's have a look at the code. So here, we're having an Express application. We're creating we're instantiating the app here, and we have two endpoints. So we have this get for the grades, and this endpoint, and the patch request for the grades. So here, what do we have? We do have an empty object for the lookout, and we're adding the student ID, the subject ID, and then the grades. And then by using this endpoint, we have all of this information that we've actually seen a little bit earlier. And how can we update this? So using the patch endpoint, we would have the same. We'd have an empty object where we'd have the student ID, the subject ID, and this is where we could potentially tamper with the grades. And we'd have the update function, which is here. And yeah, we'll have a look at the DB fetching the grade. In that case, for get the grades, and for update grade, we'll actually change the value within the database. So as you can see, the grade function contains no access control restriction. This is the one that we're talking about. There's no access control restriction on this function. And as a result, anyone who can send requests to the web server is able to update the grades. So how we can mitigate this, because we don't want to have broken access control within our code base. So in recent years, application frameworks have come a long way. Unfortunately, frameworks do not yet have the capability of automatically implementing permission structure. So permission structures still need to be implemented by the developer, because every application has specific custom requirements, and this will depend on your application. So in most cases, the reason that access control is broken is simply because it hasn't been implemented, in which case, of course, the mitigation is to implement it. Simple as that. So if we were to implement some rudimentary access control on the get endpoint in the code above, it might look something like this. So we'll have the same piece of code. So this is exactly the same one that we had previously, but we're adding this piece of code to actually check. So here, if the current user of student is not the request query student ID, then you'll have an access denied. So basically, if it's not supposed to be your grades, you won't be able to see it. So this is one way to actually prevent this kind of issue. So in this case, the get current user function would return the details of the currently authenticated user, and this will be based on their API key. So if the user ID is not the same as the ID they are requesting, then it will return an access denied message instead of the grade details. So that was for the get request. Now let's have a look for the patch requests. So the patch endpoint presents a different problem, because here we want teachers to be able to upgrade the grades and not the students. So in this instance, we need to implement role-based permissions. And an example may look like this. So we still have the same snippet of code that we had earlier, and we're adding this. So if the current user role is not teacher, you'll have an access denied. The current user role should be teacher, and then the teacher will be able to upgrade the grade. So the code above will return an access denied message unless the user role is set to teacher. And this is deny by default. So when designing a permission structure for your application, it is best to implement a deny by default mentality. That is, we should deny all requests to all endpoints by default and require allowing specific users and role for any interaction to occur with that endpoint. So many will be familiar with this topic known as allow listing and deny listing. And one fun fact by Patch, which is Nissan Leaf. So in 2016, someone discovered not only could he connect to his Nissan Leaf over the internet, but also and control features, but also he could control other people's car as well. How did this person accomplish this? By using broken access control. Oh, that's an interesting one. So Nissan Leaf is the electric car from Nissan, and apparently by performing broken access control in either, they were able to control other people's car as well. This is quite scary, actually. There's an interesting article from Troy Hunt on this if you want to learn a little bit more about this. Yeah, Vandana, if you can share it on the chat, thank you. Yeah, and he's explaining actually how he was able to, well, the attacker was able to control vehicles, features of Nissan Leafs across the globe via vulnerable APIs. Quite scary. So if you want to learn more about broken access control, so there are excellent learnings on the OWASP authorization cheat sheets, which is this one. There's way more examples and going more in depth. If you want to learn a bit more about those, you want to have some recommendation, especially like enforcing least privileges, deny by default, validate the permissions on every request, because we've seen this with the get and patch requests in the example with the student Ezra and other things. What else? See some statistics on broken access control vulnerabilities on the OWASP top 10 pages. Yeah, so there's on the OWASP top 10 website, there's obviously one dedicated to the broken access control. Well, we have a little bit more information and metadata also on this vulnerabilities if you want to learn more, also how to prevent that. And the last one is one package role and attribute based access control from Node.js, which is this one. Access control, this is a package that you could potentially implement within your code base to have this role-based access control. Yeah, and yeah, we actually managed to come at the end of this this lesson for broken access control. Yeah, what do you think, Vandana? Isn't it scary actually that a student just tampering with those requests could actually change his grades and manage to get A's?
Yeah, absolutely. See, it looks interesting, but at the same time, it's more scary. That's why people have been worrying about it, and this has been changed to top list. Like broken access control, think of this has been there for almost ages, right? Like since we were kids, this has been there. Now we've grown up, we have seen this, but now it's coming on top. It means that this has become a big concern and this needs to be addressed. And if we don't work on it, we're going to have a big trouble. And it actually encompasses multiple things. Like it's not just like a single, we say that, oh, there's a broker access control. No, there's a big chunk which needs to be addressed.
As you mentioned, Vandana, here you can see, so basically the organization OWASP, they're releasing this OWASP top 10 list every 2-3 years almost. And we've seen that the last one was 2017 and the new one is 2021. As you can see, the changes in the ranking. And as you mentioned, broken access control is going to top actually, because it used to be injection, but now it's broken access control. So this is really something that we should tackle within our code base to make sure that we don't have this.
Absolutely. I totally agree with you. And one more thing that I want to highlight here is that not just the top 10 list, you should always look at OWASP testing guide as well, which will give you in-depth information about that. For example, we know that the broken access control is on top. We have looked at OWASP top 10 list. We have looked at OWASP cheat sheet series. They're giving us good information, but they are also highlighting to OWASP testing guide. So you can actually look at that as well, because that will give you the kickstarter to how you can get yourself started in security, or you can get to know more about this information.
Yeah, definitely. The OWASP top 10 is it's a starting point for security teams and developers team. Because if they don't know where they want to start, this is actually a good starting point. But obviously, there's more than those top 10 vulnerabilities, and there's also other resources at OWASP that help you testing those vulnerabilities and make sure that you mitigate and prevent them within your code base.
Yeah, absolutely. I totally agree with you.
Cool. Also, I wanted to share one more article that Brian Clark actually did write on 5 best practices for building modern access control for cloud applications. So if you're interested in implementing access control for cloud application, this is also a really good piece to learn. Yeah, if you could also share that on the
Yeah,
chat. Thank
I'm
you.
just sharing.
Yeah. Cool. So yeah, Brian is going through all of those. He actually had his sit down with Arways, who's also a Snyk ambassador, and they've actually had discussions around those 5 best practices for modern cloud access controls.
All right, it's going to be here.
Cool.
Yes.
So we've actually done one lesson. That's cool. Let's move on and let's have a look at the server-side request forgery. Vandana, tell us everything about this. What is
Oh, yes,
server-side request forgery? I'll let you share
absolutely.
your screen. I'm just gonna move this.
Yes. All right, let me share my screen. And once you're able to see my screen, you let me know. Ready?
Yeah, all good.
Amazing. So let's talk about the interesting aspect. We started off with our session around uh, Snyk learn.snyk.io, where you have all the learning paths. Now, the interesting aspect comes is that there are lessons that we just walked through about different languages, about different and different parts of the information. Now, I'm going to be talking about SSRF. Now, what is SSRF? That's interesting to know. So here is the lesson about that. In very basic term, SSRF stands for server-side request forgery because it's happening on the server side. I am a user and I am doing some kind of a forgery towards the server in a very, very plain language. Now, the interesting bit comes is it's a vulnerability which happens when an attacker is able to trick a web application into sending a request to the server and getting the resource. For example, I want some information from Sonia, and Sonia doesn't want to share. So there is a validation there that she checks it. But uh, in another case, I send some information to Sonia, and Sonia gives me all the information, wherein she was not supposed to share. So this can happen where an application allows a user to specify a URL for a specific resource, which application access has access to without even proper validation. Now you must be thinking that how does this all work? So let's take this example. Let's take this lesson that what SSRF is and how SSRF is working. In this lesson, we would be walking you through with an example that how SSRF vulnerability can be exploited with just a URL. So one of my friend wanted to set up a beautiful app, like a new app, and who's a very well-renowned serial entrepreneur. Now, with that, when the person wanted to set up this whole new app, the interesting bit came is that it wanted to be like a social networking app like Facebook, or maybe something different, maybe something which is interesting for the people. So when she decided to set up the social networking app, she mentioned is that Mitra, because Meta was already taken by Facebook and it's already in use. So she mentioned that Mitra. Now there is a meeting tomorrow where she wanted to have a minimum viable product, wherein the product is running for a demo. So everybody, all the investors can see that. Interestingly, she asked the devs to create a URL which she can access it. She can pull in some request and she can upload picture from anywhere. So now interesting bit is that this is a functionality. Now, when the user actually sends the request in the image URL, the server is actually taking it because there is no validation there. Server is supposed to, it's a functionality, so server is supposed to do that. Now, server returns back with the image to the user and then update the profile image. So if you are sending a URL, external URL in the request form where you have your own image, you can just upload it. Now let me show you how. So here I have my terminal where I'm going to put this URL where I'm going to request for some information from the server side. Let's see what happens. It gives me some information because it's getting something from the local host. And if you look at this, it's an image URL, and image URL is getting updated. We are giving XYZ URL for myth.com. Now, interesting bit would be to get some information from the user in the form of ports. Am I supposed to get any information about the ports from from the server side? No, but that's the functionality, so we should be able to get it. Let's see. So here, when we try to recon that port, there is an interesting bit which came here is the password reset link. Interesting. What more information can I get? So here we got really good information. I can play around with the admin app. Like, who doesn't want to play around? I want to have access to anything and everything that I'm working on. I want to get the list of users, passwords, their keys, and whatnot. So what I'm going to do is I'm going to get the list of user if I can. So here, when I ran that in the image URL, I have put in the localhost link. So it's reconning the localhost on port 5000 and trying to get the user list. So let's see what it gives. Here, it's a Mitra admin portal trying to get the name, email, date of birth, address, credit card information. So admin, email address, date of birth, address, and the juicy bit, which is the credit card information. Wow, I can use this credit card. So in India, without OTP, it doesn't work. But at a lot of places without OTP, the credit card works. And maybe at some places, we don't use OTP at all. So if I have all the information, I would like to exploit that. Now, this exploitation, it gives you the access to full users. And if it gives you access to list of full user, which means it will give you access to the whole list of credit cards as well. That is one popular attack that happened on Capital One. Now, another very popular method for escalating SSRF, which is server-side request forgery, could be on AWS, on the EC2 instance, which I'm going to show you today as well. So this metadata endpoint gives you the valuable information that you need to pivot within the enterprise, to pivot within the organization, and get the information that you're looking for, or maybe even more about that. So server-side request forgery is an interesting vulnerability, which can be harmless or which can be very, very critical at the same time. So in a typical SSRF attack, any attacker might be able to get the internal only services information or would be able to get the authorized credentials as well. It can be that tricky. So attacker can exploit this vulnerability by just sending simple crafted requests like we did. There was a URL, there was a request parameter where instead of providing the actual image link, we tried to recon within the server and we could get the information. So we're just blindly following the URL and the attacker is getting the information. Now, a successful SSRF attack looks like this. But think of that situation where the attacker got access to so much information in case of Capital One. Now, this is an example, another example wherein I'm trying, the background is all set where I wanted to show that, okay, there is an SSRF, but then I am sure you want to know more about it. So let's go through step by step. Here, we will not be talking about capital 1, we will say capital 10, and we would be portraying, or I would be portraying as Bob, who tried to access the information, who tried to play around with it. Now, there is a URL that I need to use. So here is my capital 10 URL, which I'm trying to access. Now, there is something in the background wherein it gives me the username and password. It's just an example. So it's showing it looking like it's a AWS, but It's just the capital one URL where I am using this to sign in. Now here I am signed in to my account. Now I want to change a picture here. So I'm going to go to more services and I'm going to change my credit card image. So this is my credit card. I want to either upload image by taking a screenshot, putting it here, or maybe doing something different. So I have a picture on my system. This is like a mountain picture, which I'm going to drag and drop and upload it. Now, when I upload, if you see, there's some information that I get here. It says that it's an S3 bucket URL. Now, as a user, I should not be getting the information. Or, for example, it's not even S3. It could be something else. But there is an input parameter. Instead of that, if I want to use something else as well in place of that. Now let me see what information I can play around with it. So here, this is a PNG. Let me put the URL. I replaced that URL and changed it with the URL that I wanted. So if you see, it says cat memes. And let's see if it gets updated. Interestingly, that gets updated. Now, let's see what was the code, where was the problem. Now, I have this code where there's a public string, there's a document method which is used to upload the image file. Now, when that's there, another interesting bit comes as there is a URL that is being called in the query string. And in that URL, there is some information that is getting parsed. So this URL query string is then passed to an argument, which is downloading the image or which is responsible for downloading the image in the S3 bucket. Now here, finally, we are able to load the method. In the whole process, there's a URL being called, the input is being taken, sending it to the function, and then it's downloading the image or it's uploading the image. Now that's done. This simple. Did we see any input validation anywhere? In the whole section, I could not see the input validation in the simple code. Now, instead of this nice URL, if I want to upload some URL which could be fishy or which might give me the information. So if you look at the internet, this 169.254.169.254 is like a generic URL to for the AWS accounts. Now, I am trying to get some information using that. Not necessarily every application is vulnerable to SSRF. So they would be able to give you the information. Or interesting bit would be that not everyone is hosting their data on AWS. Could be on GCP, could be on Azure. So we're just trying to exploit what has happened with capital 10. Capital 10. Right. Now let's see what information did we get. Now, when I tried to play around with it, okay, let me enter. It gave me some information. Okay, there's a serialization error, but then I could get some backend information. Am I supposed to get this metadata? No. So it gives me AMI ID to launch index to everything that I want. Now, what I want is more information. So I want some information about the credentials. I know how to pivot. Okay, let me copy the URL, let me paste the URL and see if I can get the IAM credentials, identity and access management credentials from there. Okay, interesting enough that I get the information about this role, which is ISRM WAF role. Wow, what else do I want in life if I get such kind of information? So let's go ahead and try more about that. Okay, so let's get to know more about this role and see what it gives me. So if you see, it gives me an access ID and it gives me a secret access key and token. Do I need anything in the world apart from this to access it? No. I can access anything and everything using these credentials. So let's set up things. Now here, I tried to set up the account and on my local system. I am Bob. I have the access ID. I have the secret key. I have the token. The best thing in the world. Now I am trying to recon and see what else I get. If you see, it gives me every information about the S3 bucket. And if I want something more, if I want something else, if I want to delete something, I would have that. It can be that critical. So when we talk about SSRF, we just played around with a URL or an input parameter and was able to recon the information. Now, let me give you some information about how exactly we can play around with these roles. Right here, if you see, we use the URL, we try to curl through the users. Here, we are trying to curl through AWS credentials, and we got it. Like almost a similar thing that we did there. And here it is with Mithra. If I want to scan the ports, I would be able to scan it. If I want to do something else, I might be able to bring down the server, might be able to do remote code execution. So SSRF is sort of a remote code execution which can be done on many websites if they are vulnerable, if there is no proper input validation. And input validation has been one of the big challenge for every organization, whether to whitelist, blacklist, and what to do with these. So very, very important we understand these things. Now, another challenge with SSRF is that how it can be exploited when we are able to access internal resources. So we were able to access the internal URL and we were able to play around. We would be able to maybe get access to a local file on a server or making a request to the database and get every possible database. Like in case of Capital One, user was able to get access to all the credit card, like one big breach on that. Another one was port scanning. So I would be able to get access to internal ports and see what all ports are running what services and plan a proper attack based on that. So there are not just one attack that we are planning. We are going to do the multiple attacks. Um, Proxying attacks, when an attacker use this SSRF to proxy their attack to the vulnerable through the vulnerable server and making it to the attacker machine. So I am an attacker attacking the vulnerable machine, and that vulnerable machine is attacking further. How interesting that would be. And if anybody would be catch hold of that vulnerable machine would be caught. So this can help attacker avoid detection and bypass security controls. That has happened and that can happen at any given point of time. So another interesting bit would be to exploit the cloud-based services like we just did in case of S3 bucket or could be EC2 instance. So where many cloud-based services provide APIs that can be accused, we need to have um, a very much or very good understanding of our APIs, and we need to give them either the just-in-time access if needed, or the access that's needed. Not more than that, not less than that. Like we were talking about broken access control, sometimes we don't even realize that access has certain issues. Because if I'm an attacker and I know there is an API problem, I would be potentially using or exploiting that API and gaining access to the sensitive data or taking control of the victim's resource. I would want that. Another vulnerability or information leak could be from a cross-site port attack. That's called XSPA. We would be sharing all these links in the comment section where you can get to learn about them. And so in XSPA or cross-site port attack, what happens is that an attacker can use SSRF to bypass cross-origin resource sharing, which is called CORS policies, and access resources that are not normally accessible. Like I should not have access to XYZ, but now I have access to it. So these are just few examples of how SSRF can be exploited. And there are many organizations who have reported breaches over the years around SSRF. Capital One is one of it, and the recent one, if I have to talk about, is Atlassian. Let me see if we have it here. Yeah, so this is the one. With this was like a full-blown example of remote code execution via OGNL, which is Object Graph Navigation Language. An attacker was able to execute a code on the internal Confluence server, and they reported it, and it was fixed on time. Um, we would try, and then another was Capital One, which I talked about, where the data breach that exposed 140,000 social security numbers in 80,000 banks. Oh my God, that's such bank account numbers. That's such a big number. Give me 1 second. Let me show you. We have, when you come here, um, I have, yeah, okay. So if you see here, you can get to learn about everything here, and even there's a big blog, nice blog here written by my friend Riaz Walikar. He's exploited this vulnerability in many ecosystems and created a nice blog which you can go through about EC2 instances and how they were able to exploit it and how they pivoted within the network. Now, coming back to this, you can actually run through this app, run through this click through solution yourself, and you can try this on this click through that how this is working. Another example of this vulnerability is Equifax. So in 2017, Equifax suffered a massive data breach that exposed the personal information of more than 143 million people. The breach was caused by an SSRF vulnerability um, in the ecosystem, and there was major information that was leaked. Very, very major. Another example was Yahoo in 2015, where Yahoo suffered a breach that exposed personal information of more than 500 million users. Another was Hacking Team, where in 2015, the Italian security firm Hacking Team suffered a breach that exposed the sensitive information about their source code to whatnot. So these are some big breaches. Now we are not making it up. This information is available online. Sonia has been sharing good information, the links about them. Now, what can we do to mitigate this vulnerability? How we can fix it? There's any new vulnerability that comes in, there's a fix that comes in with it. It is not new. It has been there for a very, very long time. Like we exploited the information and we tried to play around with it. So how does this work? We were able to determine the URL. We were able to pivot within the network. We were able to get the AWS information because the URL was not getting validated and we were able to play around with it. So pivoting to internal user, getting the information, which actually led to a big impact. It could be harmless as well, but then it's common. Now we were talking about OWASP top 10 list. So before going to 2021, let me talk about SSRF, which is like a fresh added to the OWASP top 10 list 2021 because this had such a huge impact on many organizations that even though the data that was gathered for the analysis, that didn't show it as like a big issue, but then all the organizations came back and said, no, we need to have SSRF as part of the top 10 list so that people understand, organizations understand that yes, this is a concern. This is actually a real concern. Now, there was an exploit which was discovered by Justin Gardner in a popular open source application called Grafana in 2020. And we can read more about it here as well. There was a video that was also created around that how this vulnerability is impacting the application. Now, with these videos, we're trying to share as much information as we can. Oh, my favorite part, mitigation. We have tried to get to know about the vulnerability, what this vulnerability is all about. Now I'm trying to get more information about um, like how do we mitigate. So if it's necessary to accept dynamic and part of the request, we need to only accept the defined things. If a host name is defined, let's check why do we need IP address. We need to be very clear about redirects. Redirects are very common. That used to be a vulnerability, even though now we have tried to fix it, but still we need to be very clear there is no internal redirect that's happening. If it's only supposed to give you certain URL set, get the certain URL set, it should not give you the internal information. Check if internal IP address, if the IP addresses, how exactly they're binded. We should not be giving any information about the internal information set. Like if you give me, I would be very, very happy, but it should not be there. Now, the problem is that the IP address is, if let's say fetch twice, the first time to check the IP address, the second time to make the request. If it's trivial to create a DNS server that responds um, to these requests with a different IP every second, if it occurs when the IP address is checked, it might be an external IP address as well. So while doing these requests to the server, we'll have to be very, very, very cautious. Now, we need to also have a very clear understanding what's allowed and what's not allowed. If we don't have that information, we would never be able to get the right information. And another interesting aspect is that we can actually test it out using the static code analysis tool. We can test it via dynamic application testing as well, because we can check the input validation. If we have a SAS tool set up in the pipeline and we realize there is improper validation, and we would be fix it. And then if there is a URL redirection, or there is a URL parameter which might get redirected, you would be able to put in the right validation there. Now I'm going to stop here, and what we're going to do is we're going to do a quick recap of what we discussed here. So let me go back to my Snyk Learn page. And here, what we discussed as part of the lessons, we learned about there are different languages and in Snyk Learn. And in Snyk Learn, we can go to JavaScript, Java, and we can learn about different issues that are there. We keep working on creating more and more information around it so that you can do all these click through vulnerabilities. You can just try them yourself and you get to know what these are. We've tried to share the attacks, resources, and everything. We started off with broken access control, and now we are ending up with SSRF. We will be covering a few more attacks in the upcoming days, which will give you information. Now I'm going to stop here and see if there are any questions. Sonia, do we have any
There's,
questions?
there's also one thing, just let me share my screen. So
Sure.
I've demoed with the JavaScript example, and you've demoed yours with
Mm-hmm.
Python. If you're more familiar with another language, actually what you can do is click a little drop down here, and you can select another language. So if you're not familiar with JavaScript, but you're more familiar with Python, you can actually click on this one, and then the example will be Python friendly in that case. Yeah, and the same for your lesson for the SSRF. If I go back to starting path, that was top 10. You can actually select one of the languages that you're more familiar with. So you've demoed, Vandana demoed with Python. You also have it available with JavaScript. They're more familiar with this. Yeah, just want to make sure that you had that also that information, because sometimes people think, oh, I'm more familiar with one ecosystem other than the other. So no excuses for learning. We do have lessons available in Python and JavaScript. Also, at the end of the lesson, if you scroll down at the bottom, you have a small FAQs just to review the bullet points and items that you've seen during this lesson. So it's usually what is the vulnerability, what are the impacts, and if it's part of the OWASP top 10 and other useful information. And if you're eager to learn more outside of the OWASP top 10, we do recommend a few more lessons on it. And you can see there's like fresh new lessons. How exciting is this, Vandana? We did release for Python vulnerable and outdated components, because we had that one for JavaScript, that this one is available now for Python. We've released JavaScript X path injection, and for PHP, also showing a little bit of stuff for the PHP ecosystem, no rate limiting. So yeah, you can actually learn all those vulnerabilities. And even if you're not familiar with the language, you can still get the gist of the vulnerability, because it's just the programming languages which are changing. Usually the security vulnerabilities stay the same. So yeah, regardless of the programming language, just learn more about all of the security lessons. And the good thing is, all of this online platform, all those goodies, it's free. So yeah, you can start learning today. How amazing is that, Vandana? All of this is free.
Absolutely. I totally love it. And I do want to share one more information. I think I missed out, or we want to share about that. So if you see here, the interesting bit is that we can take different lessons which are related to these bugs. So let's say if you want to know about broken access control, but there is something more attached to it, like insecure randomness or insecure hash, you would be able to do it. You would be able to learn about weak password discovery, or you will have some interesting recommendation from the testing guide, which will directly open here. So these information, as Sonia said, it's completely available for you, and you can use it and give any given point of time. You can share it with the people who want to learn about all of these things, especially the students, especially the developers who want to understand about these issues. One thing I've realized over the years that developers understand the ecosystem so well that if they understand the vulnerabilities, they would be better security researchers than us. That I can assure. So it's important that we understand these bits. And with this series, the 5-part series, what we are trying to do is we're actually trying to share that information.
Also, one more thing that you could do, because we're within this period of the big fix. So the thing is, you could also potentially leverage the Snyk tools. So including the Snyk vulnerability DB, if you want to learn a bit more about those vulnerabilities. So for example, for broken access control, this is a good example of one of the packages that was vulnerable to this one. So going through the Snyk vulnerability DB, you can have a look at the most comprehensive, accurate, and timely database for open source vulnerabilities, depending on your ecosystem. And you can see we're actually covering a lot of the languages and ecosystem, just to have like a real life example in the world how it looks like. If you want more examples, and we do feed that database daily. So this is also a good resource to have a look at. And the other one is Snyk Advisor.
Mm-hmm.
So we do have 4 packages for ecosystem, sorry, npm, PyPy, Go, and Docker at the moment. Again, if you want to learn a bit more about potentially like malicious packages, or if you want to just check the health of a package before implementing it within your code base. This is a good way to actually see. Just like a quick example with one package which has the perfect health score, but basically it's giving you a little bit more info around like security, popularity, maintenance, and community. As you can see, if the package is free from security vulnerability, if it's well maintained, which is important to see when it was last released, last committed, the popularity of the package, and other metadata from the community. So those are like tools if you want to implement packages or make sure that it's free from the vulnerabilities that we've mentioned, because we don't want to have SSRF or broken access control within our packages or within our code base. So potentially those are tools that you could use to leverage that. Yeah, and just leverage the big fix opportunity, the month-long fix lesson to actually fix your security vulnerabilities within your open source software, your open and closed source software. Yeah, just try to make a positive impact. Let's fix those vulnerabilities.
Absolutely. Let's fix these vulnerabilities, and at the same time, let's join together on February 28th for the live stream, which is going to start at 12 a.m. GMT and going to run till 12 p.m. GMT. So it's going to be like a whole, or 12 a.m. itself, like 12 a.m. the next day. So it's going to run for the whole 24 hours, and it's going to be very, very interesting to see. We have a lot of speakers from APJ to EMEA to AME region, and we would love to have you there and see these bug fixes. It'll be totally amazing.
Yeah, you're starting, you're launching, you're actually kicking the story with the APJ. You can see hosted by Bandana for APJ. And yeah, for like 8 hours, right? This is going to be amazing. And yeah, just join us. And if you have any questions, we could interact and like answer your questions during those live stream. But you can see there's a lot of interesting topics that we'll talk about during this 24-hour live stream. As you mentioned, you don't need to stay awake for the 20 or 24-hour live stream. All the sessions will be recorded. If you missed some session, you can watch them on our Snyk channel, our YouTube channel. But yeah, if you feel adventurous, just stay up with us for the 24 hours live stream.
Absolutely. Great. So, thank you so much, everyone, for joining today's stream. We would love to see tomorrow with 2 different vulnerabilities, which are very, very interesting. And we would love to have you interact with us, ask questions. If you didn't get a chance to check about this one, just do check out. And it's going to be there on the YouTube. We would love to see you there. And share as much information. Maybe, see, we are sharing this bit because it's just a half an hour, and these vulnerabilities take time. You might be give us some more insight on it. So please feel free to talk about that. And tomorrow we have the injection, and there's another interesting vulnerability that is going to be picking up as part of it. So we would love to see you join us for injection and insecure design.
Yeah,
And
so
stay tuned for it.
be there tomorrow for injection and secure design. It's going to be an interesting one. Thank you for
Yep.
coming and yeah, joining this
Thank you for
session.
joining us. Thank you so much.
See you tomorrow.